Okay, welcome to the video about exponent rules, or sometimes called power rules, because we know when we have an exponent it's also called being raised to a power. What I want to do is go through these rules with you and show you them separately, and then at the end we have a couple examples we'll do where we're combining the rules. Okay, these are not related to situations. This is sort of just algebraic practice and simplifying rules or situations when we have multiple exponents. So the first rule is called product of powers. Remember, product means when we multiply. Powers is when we have exponents, so we're multiplying when we have exponents. And the important thing to note here is that we have two terms with the same bases. So we have the same bases, and so we must add the exponents. So let me show you this out in long form. The base is the big number on the bottom, right? So in long form, the reason we add the exponents is, let's say we have, for example, 5 squared times 5 to the 4th. Well, that is 5 squared is 5 times 5 times multiplied by 5 to the 4th is 4 5s, 5 times 5 times 5 times 5. So how many 5s do we have here? Well, 1, 2, 3, 4, 5, 6. We have 5 6 times, or 5 to the 6th power. And so we've just added the exponents. If we want to do this in a more simplified version, we don't have to do it out the long form. We can just do b squared times b to the 3rd. But we just know we're going to have to add those, so this is going to become b to the 5th. That's with variables. Or another way we might see this is x to the 4th multiplied by x to the 3rd. Remember, parentheses mean multiply, so we multiply these. This is going to become x to the 7th. One last example maybe. We have a to the 6th times a to the 12th. Well, that becomes a 6 plus 12, the 18th power. Okay? So, same bases, add the exponents. Let's look at the next example. Quotient of powers means we're dividing. A fraction bar also means we're dividing. So we have two bases. We have the same bases again. But we're going to this time subtract the exponents. Okay, subtract. Let me show you out an example. If we have 3 to the 4th divided by 3 squared, well, 3 to the 4th is 3 times 3 times 3 times 3. 3 squared is just 3 times 3. We can cancel. We know 3 over 3 is just 1, and 3 over 3 is just 1, so we're just left with 3 times 3, or 3 squared on top, over 1, which we don't need to put. And you could even do out 3 squared, because that's easy enough to figure out. That's going to be 9. So notice we've done 4, subtract 2, just leaves us with the 2 for the exponent. Another example might be 10 to the 7th over 10 to the 4th. 7 subtract 4, that would be 10 to the 3rd. Or if we do an example with a variable, y to the 4th over just y, remember, if there's no variable, that implies that if there's no exponent, that implies that it's an exponent of 1. So that would be y to the 3rd, because we've done 4 subtract 1. When you're dividing, subtract the exponents, as long as you have the same bases. Let's look at the next page. So power of a power means we have an exponent being raised to another exponent. Okay, so we only have one base. We have an exponent raised to an exponent. We are going to multiply the exponents. Let me show you this out why, the long form first, of course. 5 to the 4th squared means do 5 to the 4th 2 times. So that means do 5 times 5 times 5 times 5. That's the first time. And then we have to square that, so that means we have to do that again, times 5 times 5 times 5 times 5. So how many 5s do we have here? Hopefully you're seeing we have 8 5s. So I've done 4 multiplied by 2 to get 5 to the 8th. If we have 2 to the 3rd to the 5th, that's just going to become 2 to the 3 times 5 is 15. Or with a variable, we could do it like this. If we had 5 raised to the a power raised to the b power, that's going to be 5 to the a times b. We're just going to multiply the variables. We know if they're just next to each other, that means to remultiply. So one base, an exponent raised to an exponent, we multiply the exponents. Multiply. Moving along, we have the power of a product. So that means we're multiplying and we have an exponent on the outside. Okay? So it looks like what we end up doing is sort of like the distributive property. Okay? Distribute the exponent to all terms inside the parentheses. Again, the reason we do this is because we are multiplying and then raising to exponent. Let's do a long one out. 6 times 5 raised to the 3rd power. So that means we have 6 times 5 3 times. Okay, we can put the terms together, so that means we have 6 times 6 times 6 times 5 times 5 times 5. And so 6 3 times is like 6 to the 3rd times 5 3 times 5 to the 3rd. So we've distributed the 3 to both parts inside the parentheses. Another example with this might look like a 2 times x raised to the 5th. Well, that's going to be 2 to the 5th power x to the 5th power. Here's where you have to decide if you want to do out 2 to the 5th. We might say 2 to the 5th is 32, and we still keep x to the 5th. So sometimes it's better to do out the exponent if it's an actual number raised to an exponent. Sometimes that just gets to be such a big number, it's actually easier to keep it as an exponent. Here's one where we could combine 2 of the last rules here. If we have 5x squared raised to the 4th, and we distribute that 4th to the 5 and to the 2, so that becomes 5 to the 4th. That's the easy part. But here I have x squared raised to the 4th. If we remember the rule just above this one, if we have a power raised to a power, we multiply those. So that's going to become x to the 8th. So there we've used 2 rules to simplify one situation. All right. Power of a quotient. Similar to the one we just did, if you're dividing inside a parentheses and you have an exponent outside, you're still going to distribute the exponent to both terms. Okay, so the m is going to go to the x and to the y, like the example there. Let me show you why we do this in the long form, right? 2 over 7, 2/7 raised to the 4th power. Well, that means 2 times 2 times 2 times 2, and 7 times 7 times 7 times 7, or 2 to the 4th over 7 to the 4th. This might be one of those situations where it's cleaner or simpler to leave it like that versus actually doing out what 2 to the 4th and 7 to the 4th is. We can mix, again, variable with a number. C over 9 to the 6th just becomes C to the 6th over 9 to the 6th. Or we can even mix a, let's see, let's do 3 over 6, 3a times 6 raised to the b power, all squared. So we have to do the squared to the a and the squared to the b. And we know we multiply those, so this is going to become 3, 2 times a, over 6, 2 times b. Because we multiply when we have a power raised to a power. And we had to do the distributive property to both the top and the bottom. Okay. Negative exponents. When you have a negative exponent, we've talked about this a little bit, it means that you're going to make it into a fraction and put the base and the exponent in the bottom of the fraction and make the exponent now positive. The easiest way to sort of see this is to start with what we know about 10 to the 0th. We know is 1. And we know 10 to the 1st is 10. And we know 10 squared is 10 times 10, which is 100. And so we could continue that. 10 to the 3rd is 1,000. Okay, so it looks like the exponent is the number of zeros in our answer. Can we anticipate that 10 to the 4th is 10,000? 4 zeros. So what happens then? We have 10 to the negative 1. Well, I can't have negative 1 zeros, but what this ends up being, if we use the rule here, this becomes 1 over 10 to the 1st, which is the same thing as 1/10, or 0.1. Okay, so we're 1 below 0, maybe you can think of it, 1 away from 0, in the negative direction, or in the decimal direction, or 10 to the negative 2 has become 1 over 10 squared, or 0.01, 2 away from 0 in the decimal direction. If we look at 4 to the negative 2, this is just going to become 1 over 4 squared, or 1 over 16. If we have, in a mixed example here, a cubed times a to the negative 7, well, a cubed just stays where it is, but this negative 7 part has to go on the bottom. That's going to become now positive 7. Oh, here we have 2 bases with 2 exponents. The bases are the same, so we can subtract 2 subtract 7. I'm sorry, this should be a 3. Hope you're all catching that. This should be 3. I don't know where I got 2 from. 3 subtract 7 would be a to the negative 4. Well, we know if it's negative, we have to have 1 over a to the 4th. So there we've combined a couple rules along the way to get our final answer. Or we could have something like xy raised to the negative 2nd power. Distributive property to both parts. This becomes x to the negative 2 over y to the negative 2. Now, here's where it gets tricky. We know the one on top, excuse me, needs to go on the bottom to become positive. If it's negative on the bottom, it's going to come up to the top, the numerator, to become positive. So there's an example we want to remember. All right, we had just talked about this. 0 exponents. I think I just shown you in the other example, 10 to the 0th is 1. Remember, anything to the 0th is 1. Okay, we could say 3,572 to the 0th is 1. One of the fun things about the 0th rule is you could have something crazy like 5xyz to the 4th all raised to the 0th power. You got it, it's 1. Or even 3x over 5y squared all raised to the 0th power, 1. So there's a nice sort of relief for us. We can always know what that is. Let me give you one example here to leave you with, where we combine a bunch of the different rules, okay? So let's say I have 2x to the 5th raised to the 4th multiplied by 5x to the 3rd squared. Well, it looks like the first thing, just like with PEMDAS order of operations, we need to take care of the parentheses first. So this sort of distributive property of the exponents needs to happen. So we're going to have 2 to the 4th x. When I have a power raised to a power, I multiply those. So that's going to be x to the 20th times 5 squared, x to the third, raised to the second again. I multiply those, so that's going to be x to the 6th. I can do out this because 2 to the 4th, 2 times 2 is 4, times 2 is 8, times 2, so that's just 16, x to the 20th times, let's see, 5 squared, we know it's 25, sorry about that, x to the 6th. Numbers I can just multiply. 16 times 25 happens to be 400. X to the 20th times x to the 6th. That was the very first rule we started with. Same base. We're multiplying. Add the exponent. So this is going to be x to the 26th. Add the exponents. Hopefully, this all works for you. Bring questions with you to class, and we will be practicing this for a couple of days.